Yeah, when Mariska first asked me to talk about cBioPortal developments and support in the EU, my first question was actually, okay, what am I going to talk about? Because we work mainly with pharma companies, and they're mainly based in the US. We just did a couple of projects in Europe, but they were actually not even in the EU. Well, one of them is in the EU, but won't be in the EU anymore next year. So I was thinking, okay, what should I say? Then I figured that we're actually the biggest development team outside of the US. So I thought we could, talk about what we do, even though that it's work for pharma companies that are outside. The work is actually done in the Netherlands. So I'll be focusing on that. So I'll give you a quick introduction and then talk a bit about our work and also about what I think we might be doing in the future. Well, the Hive, of course, most of you already know. So I'll be very quick about this. With some core values and a mission, and share and reuse, of course, very easily tied to open source. And specialize is also very important, of course, because you cannot do everything. So we specialize in life sciences. We're 40 people working. We're based in Utrecht. And what we basically do is we provide services around open source software and data. And I'm actually seeing that on my other screen. My slides are still not showing. Let me fix that. Let's see. Because it opens in a new window. That's not very convenient. Let's just do it from here. Let's see. Yeah, this is where I was. So share we specialize, and then moving on to the Hive in practice. So service around open source software. I work with interdisciplinary teams. So it's very important for us to have a good mix between software developers, bioinformaticians, and the mix is necessary because the cBioPortal application is quite complicated. So you do need people who have proper technical background, to know about software architecture and really software development in more depth. But of course, you also need people who understand the data and understand the domain. So that's why you need a mix. And of course, you need people to understand what the client needs. So we also have a kind of role for a business analyst in the company to assess those needs. For our services, we usually start our engagement with a client first doing deployment and integrating with their systems. Mostly that's with an identity provider. A great example here is actually the Princess Maxima Center. There we integrated cBioPortal with Transmod. So you have Transmod for clinical data, you have cBioPortal for molecular data, and also for the visualizations that Transmod doesn't have. And there, of course, we also have integration with an identity provider to make sure that data access is being controlled. Data services, I think, speaks for itself. It's basically loading data either manually using some Python scripts, but also writing automated pipelines. Development, I will come back to that later. In terms of hours that we spend, training is actually a very small bit, but I do think it's one of the important ones, because here you teach people how to use the system effectively, and also to load their own data. Great example here is actually a project for UMCG, where we taught Bart to load data into cBioPortal. So that's the molecular tumor board presentation you saw earlier, and I think that's going great at the moment. So I'm happy to see that. Yeah, just a bit about the cBioPortal community. As you can see, MSK is by far the biggest group working on cBioPortal. That's both development and also curation of public data. Then, of course, next in terms of size is the Hive. Dana Faber, where maybe some of you recognize this face. He used to work at the Hive before he crossed over to the US. And also part of the community there is Children's Hospital Philadelphia and Princess Margaret Cancer Center in Toronto. So we basically have weekly calls where we kind of discuss issues with cBioPortal, user issues that are reported in the Google groups, future plans for development and things like that. Okay, so now I'm going to focus on our work, so the things that we built here in the Netherlands. First, I'm going to give a quick overview of the process. Typically, when we develop a feature for cBioPortal, we first create an RFC document. RFC stands for Request for Comments, basically inviting the community to comment on our designs. And by doing that, we try to get to a better solution for the problem that our client has, to get input. Issues we typically just use GitHub. It's unless you need like really proper design. GitHub is a really good way of doing that. Then for development, we have a couple of steps. First, you fork the main code base, and of course, then you're going to implement the feature in the fork. When you're done, you create a pull request. Pull request automatically tested by the funny-looking guy in the middle, and after that, there's a review process where other members of the community, they will look at the code, look at the functionality, and when there's no bugs or no issues, this functionality will be merged into the main code base. For the public data, the process is in principle it's the same, but we don't really collaborate too much there. So, but I would invite everybody here on the call. If there's any studies that you could make public, if you could make a pull request with that study included to the data hub on GitHub, it can be reviewed by MSK, and it can actually show up in the public portal. Let's see, the features that I would like to talk about today are, although they're not that visible for most people, I think. So these features were not in the webinars. They're also not always visible in the public portals. That's why I want to specifically highlight these. But I want to start with the study data validator, because I think that's a really important and useful one. If you're loading cBioPortal data into cBioPortal, you have to put it in the right format. So you have a couple of file formats that you have to adhere to, and you have to structure those files in a directory in a certain way, and then you will load it. Well, of course, if there's a problem with the data, you will of course have a problem in the end result. So when you start the importer and maybe there's a file missing, the importer will just crash and not really tell you what the issue is, or at least not in a very user-friendly manner. And there's also situations where the importer might actually decide to continue, but skip certain data items, which is of course also not desirable. So what we did to help the user in putting the data in the right format and preventing these data issues is create a validator. And the validator is a tool that you can run separately from the importer. And when you do it, will create this nice report. And if there's an error in your data, it will tell you what the error is, so you can fix it. And if there's something that wouldn't prevent the data from being loaded, but could potentially be a problem. For instance, you have in your data you have a gene that is not actually in the cBioPortal database. In that case, the importer would just skip it silently. And by running the validator, you can actually see which genes are skipped because of this. And you can decide, okay, I want to fix this, or maybe you decide, well, this gene is not, maybe it's not actually a gene, it's something else, or it's old or not interested. You can just skip it, decide to skip it. But at least then it's a conscious decision whether you skip it or not. Next feature I'd like to highlight is the support for treatment response data. So this is kind of implemented as all the other molecular data types are. So it's very closely, it's very similar to RNA expression data, with the big difference that it's not, the data is not associated with a gene. So what you can do here is you have a bit more flexibility. You can basically invent your own entities that you would then associate this data to, and it's really good for when you have like big matrix of data points that are basically all the same meaning, but you don't want to add like hundreds of clinical variables. So it's very flexible. And the reason why most people are not really aware of this feature is because it's only one study that has this data at the moment. It's a CCLE 2019 study in the public portal. So looking at all the other studies, you won't see this feature at all. But if you go there, you can check it out. The visualization that you see is also something that we implemented in this project. Waterfall plots are often used for these types of data. So that's basically a new type in the plots tab. But you can actually also use this for other data types if that makes sense. MSK, after we implemented this, MSK has done some work to make this feature even more general. They call it generic assay, and it's a bit more generic than the treatment response, but it's basically the same idea. So it allows you to load different data types that don't have this association with a gene. And then the next one is gene set variation analysis visualization. This is actually not available in the public portal at all, simply because we never prepared the data for all the, never prepared the scores for any of the public data sets. So the feature is there, it's sitting in the main code base, and you can use it if you have your own internal cBioPortal installation, but you won't see it in the public one. So what does it do? Basically, it allows you to create sets of genes and compute aggregate scores for that. So that you actually do this computation before you load the data. And then in cBioPortal, you basically visualize it the same way as you would visualize expression data, usually as a heat map. And this allows you to look at data in the more like on a pathway level. So here you see glioblastoma study with the Van Hagen gene sets, which basically give different, they define different subtypes of glioblastoma. And these scores make it a lot easier to see those compared to just looking at the expression data. And then there's last feature I would like to highlight is the option to store richer metadata for a study. So for a study now, you only have a few things that you can store. So there's a name, there's a PubMed ID, and I think there's also a description. We allow more structured data for that. Again, this is a feature that's in the main code base, but we haven't generated any metadata yet for the public studies. The feature is very generic, so that you can see that the data that goes in is just, in this case, it's a YAML file. It can also be a JSON file, and it will just be displayed as a table. So you can have any kind of structure here, and it will just be displayed as is, making it very flexible. And I think this is really useful to store some metadata about studies that you don't really have another place to put. For instance, here you could say, okay, when was this data loaded? Who prepared the data? Maybe there was some Jira ticket associated with it, or maybe you have some report associated with it. You can all leave that here. So it's very useful, and I think it's going to be more and more useful if people put more emphasis on generating fair metadata for their studies. So that's it in terms of the work that we've done. Just a few things about our future plans. So we're still developing new features. We have a couple in the pipeline. One is actually interesting to mention based on the previous question about ctDNA. We're making some improvements to the genomic evolution plot. I think Ino is going to show the genomic evolution plot. What we're working on is basically integrating that into the timeline together with MSK, and also allowing for the user to split samples in different groups. So you might have ctDNA samples, and you might have actual tumor samples, and you don't want them in the same plot because they will have different allele frequencies, which are they're not actually different, but they're different because of the technology and not because of the actual thing that you're measuring. So you would like to separate them. So that's something that we're working on at the moment. But since it's not yet in the main code base, it's not published yet in our blog, but it will be hopefully soon. And another thing that is kind of one of the things that I would like to achieve in the future is to have some other open source tools that would integrate well with cBioPortal. I think it's good to acknowledge that one tool cannot do everything, and also should not do everything. So it's important to integrate. And I think for us as the Hive, it's always important to find open source tools that draw a bigger audience. And to take the single cell sequencing as an example, you can probably find like 20 packages on GitHub where you can visualize single cell data, but there's no kind of clear winner. There's no tool that would cover like most of the use cases, is stable, is easy to use, and does everything you need. But we would like to find a tool that does enough, and then when you integrate it with cBioPortal, it gets a lot of extras. For instance, cBioPortal can do the chord selection before you go and actually look at the single cell data for these patients or samples. I think that would be a useful combination. And my expectation is that if you integrate something in cBioPortal and then all the cBioPortal users will see it, you also generate enough interest in these new tools, these single cell sequencing tools or pathology imaging tools, to kind of bring them to a next level in terms of funding and in terms of development, to make a mature tool out of that. And that's basically what we as the Hive would like to achieve, is good and mature open source tools. And I also would like to quickly highlight React. It's a tool developed by AstraZeneca and University of Manchester. It has better support for clinical data than cBioPortal currently has. And the DSMT is actually using this combination of cBioPortal and React to follow their clinical trials. And we're also looking into that, whether that's a good use case for other organizations. And I would like to mention that we're currently on 2 grant applications for with Cancer Core Europe. And the idea is basically to develop new biomarkers that would go into cBioPortal so that clinicians can use those to figure out the best treatment for their patients. So hopefully these applications will be granted, and we'll be working on this I guess somewhere next year. So yeah, that's it for me. And if there's any questions, happy to answer them.
Okay, so Sjoerd, thank you a lot for this overview of all that you're doing and what you were able to show us. I'm also looking forward to know what's going to happen to the Cancer Cure project, because several of us are also in those project calls, basically.